In Chapter 9, we're going to take up the topic of inequalities. Section 9.1 is also titled the same. Now, you may be familiar with inequalities already. If you recall, there are 5 inequalities in mathematics. And of these 5, we're going to primarily be working with 4 of them. These are the inequality symbols that I'm going to actually list them for you here. The inequalities are less than or equal, greater than or equal. And the 5th one I was referring to is the not equal. Now our focus is primarily on these 4. Okay. Usually in arithmetic we use inequalities to show relationship between numbers on the number line. Like 5 is less than 10, 2 is less than or equal to 7, and so on and so forth. Now, as far as the inequalities we are interested in this course about are those that involve algebraic expressions. So, we're going to set out some rules about working with inequalities. So, we got these 2 principles that we're going to look at closerly. We have the addition and the multiplication principle, or rules of inequalities. And the addition principle is very much just like the equations. Remember, in an equation, we can add anything to both sides of an equation, right? We can add or subtract anything to both sides. Well, that's what this addition principle tells us. The addition principle tells us that if you add something here, C is a constant you can add to both sides of an inequality. Now, by the way, less than, greater than makes no difference. So just showing you or illustrating this using these 2 inequalities. The addition principle works for all 4 inequalities, for all 4 of these. So all you need to know is like the first one, in case you need to just know that. And then the multiplication principle or multiplication rule of inequalities tell us that we can actually multiply or divide both sides of an inequality by any number that we like to, non-zero, anything other than 0. Now, it is important that we identify the number that we are multiplying or dividing by as a positive or negative. If the number is positive, then in that case, when you multiply both sides or divide both sides of inequalities, the direction of inequality is not going to change. We'll see example of these in a moment. On the other hand, if I multiply by negative, an inequality by negative, or divide by negative, notice the direction changes from less than to greater than. And if it's greater than, it changes to less than. So keep those in mind, please. Multiply or divide by negative, we need to change the direction of inequality. Now, the reason for that is, by the way, pretty straightforward. Let me just use example to illustrate the reasoning behind it. So, for example, suppose I have 20 is less than 40. That is a true statement. So if I add 5 to both sides, 25 remains less than 45. That's a true statement. So the focus here is on truth or fallacy of this statement. So we started with a true statement, we maintain a true statement. Then I'm going to subtract 20 from both sides. And now I have 5 is less than 25. And that is true also. Okay, so note that in the first example, the first step of this example, the first step that I added 5 to both sides, so I did addition property. I added a positive number, and that did not cause the direction of inequality to change. What I did in the second step, I actually subtracted 20 from both sides, and I still have maintained a true statement. Okay, now in the next step I'm going to multiply both sides by a random number. So I'm going to multiply both sides by 10 now, a positive number. So that's going to make it what? 50 is less than 250. Still true. And finally, let's say I'm going to divide by negative 50 both sides. Divide by negative 50 by negative 50. And now, if I continue, 50 by negative 50 on the left is negative 1. 250 by negative 50 is negative 5. Now, if I don't change, if I don't turn the direction of inequality, notice at this point, this is a false statement. And hence the reason we need to change the direction to maintain the true statement that we had before. This is false, therefore I'm going to say negative 1. And we're going to actually change this to greater than in order to force it into a true statement. Okay, and that's what this was, negative 5. Again, true. So here, again, the direction of inequality needs to be changed. And that's indeed what both of these parts are telling us. So keep in mind, again, if you multiply or divide by negative number, you need to change the direction or sense of inequality. Okay. Now, let's take a look at some exercises here. So some of the examples here, for example, let's say I want to solve this inequality. Suppose I have something not too complicated. Most of these are not even complicated. 3x plus 1 is less than 7. We need to isolate x. Okay, so to isolate x, I'm going to subtract 1 from both sides. And then we divide by 3 on both sides. And here we're going to get x is less than 2. And there we have it. Okay, now let's actually graph this. And if I graph this, this is a number line. Here's 0. And this is 1 and 2. Okay, 2. Now anything less than 2, not including 2. So what we're going to do is we're going to put parentheses here at 2. And then I'm going to shade everything below the number line. This is the graphical representation of the solution. Okay, and then we're going to also use what we call interval notation and set builder notation. In a set builder notation, we build a set, hence the name set builder. We build a set around the solution. So I'm going to have curly braces, the variable name, this line, and then whatever the inequality is, x less than 2. That would be this inequality right in here, right in here. You just move that inside the curly braces and you close it. That's called a set builder notation. In this notation, the line that you see here, we'll read that as such that. So again, this reads, the solution set is all x's such that x is less than 2. Now we can actually translate this into interval notation. In interval notation, here, if I extend my number line in this direction, the ends of number line lie these two symbols. To the right, I have infinity symbol, which looks like that. That's what this is, to the right. And on the left side, I have negative infinity. And again, those are not numbers. Again, those are just replacement for words. And this means very large to very large. And this means very small. You see that they're not numbers, more of a behavior of a number. So in interval notation, you look at the shaded segment of the number line, and we place that segment inside an interval that runs from the left, negative infinity, comma, up to 2, and we use parentheses here. If there is no equal sign on the inequality, we always use parentheses. But if there is actually equal sign on the inequality, we use brackets. So there you go. There's a solution to that one. Not too bad. Let's take a look at another one. In this one, another example here. Suppose this time I have 4m plus 7, and this time greater than or equal to 9m minus 3. So to isolate m, I'm going to subtract 9m from both sides. I like having the variable on the left side. So that's negative 5m plus 7 greater than or equal to negative 3, right? Let me fix this one up. There you go. Okay, so that's going to be... Now, notice I'm not sure whether I added or subtracted a number because I don't know what m is, but it doesn't matter because at this adding or subtracting, we don't change the direction of inequality. Next step, I'm going to subtract 7 from both sides. And when I subtract 7 from both sides, I get negative 5m is greater than or equal to negative 10. And the last step, I'm going to divide both sides by negative 5. And when I divide by negative 5, now remember, we got to change the direction. So I'm going to change the greater than to less than or equal to in this case. And there we have it. Again, on the 3 ways of representing the solution, this is a number line. So 2 would be here. It's coincidental, the same number as before above. And this time, because it's equal sign, I use a bracket here. That means 2 itself is part of the solution. And I'm going to shade everything below that. Again, there lies negative infinity there. So for this one, negative infinity to 2 with brackets. This is the interval notation. And this one is graphical notation. Now the set builder notation looks like this. M such that. And this is what we call the set builder notation. And there we have another example done here. Well, let's look at one last example in this segment. This time, this other example is going to be 5 times t minus 3 and plus 4t less than 2 times 7 plus 2t. So our first step is to remove parentheses from the expression. So to do that, we're going to use distributive property. I'm going to multiply 5 times t and 5 times 3. And same thing on the right side, 2 by 7, 14 plus 2 by 2 makes it 4t. And combine like terms on the left, we get 9t, 5 and 4 makes 9. T minus 15 less than, on the right side I just have 14 plus 14, nothing there. Next I'm going to subtract 4t from both sides. And on the left we're going to get 5t minus 15 less than 14. Next I'm going to add 15 to both sides. See, when I'm doing all of these, I don't need to change the direction because I'm not dividing or multiplying by negative numbers. And finally, the last step, divide both sides by 5, and t would be less than 29/5. There is a solution. Create those curly braces, put the variable name, and the vertical line must be there. So here's the set builder notation. On the number line, here is 0, call that 29/5. 30/5 would have been 6, right? So this is a little bit less than 6, about 4.8-ish. And again, it so happened on all of these, the ones I've done, everything was less than. And in none of them I had to change the direction. Now this time, because this is a less than symbol here, less than, so that means I need to have parentheses here. And indeed, that will be this shaded region. So the solution in interval notation is going to be negative infinity to 29/5. And that is how you solve these inequalities in this section. They're pretty straightforward. You just apply the addition and or the multiplication property of inequalities, and that should do it. So with this, we are done with this section. Again, rather short and brief section, and we're done for now.